So welcome to this session on numerical analysis. We will be learning Newton Raphson's iterative formula and how to apply it to problems. So this is part 1 of this lesson. So we start with let fx equal to 0 be a given equation. The first approximation x1 equal to x0 minus f of x0 by f dash x0 if f dash x0 not equal to 0. Second approximation x2 is x2 equal to x1 minus f of x1 by f dash x1. So we replace x0 by x1. And in general, xn plus 1 is xn minus f of xn by f dash xn. So that's all you need to remember. So coming to problems, we'll solve a couple of problems. This is an algebraic problem first. Use Newton Raphson's method to find the real root of x cubed minus 2x minus 5 equal to 0, correct to 3 decimal places. So we start with let fx equal to x cubed minus 2x minus 5. F of 0 is minus 5, which is less than 0. F of 1 is minus 6, which is less than 0. F of 2 is again less than 0, but f of 3 is greater than 0. So we say that a root lies between 2 and 3. So we start with let x0 equal to 2 and x1 equal to x0 minus f of x0 by f dash x0, and f dash x will be 3x squared minus 2. Substituting for x0 as 2, you get x1 as 2.1. Now f of 2.1 will be positive. So we can say that we have to calculate f of 2.1, and now we take x1 as 2.1. So x2 is x1 minus f of x1 by f dash x1. So this will be 2.0946. Again we replace x2 by 2.0946, and x3 is x2 minus f of x2 by f dash x2, and this is again 2.0946. So we can see that x2 and x3 are almost the same. So we conclude that the approximate root is 2.095. So coming to the next question, use Newton Raphson's method to find a real root of x sin x plus cos x equal to 0 near x equal to pi. So now we are working with trigonometric function, and we are given that the root is near x equal to pi. So we write fx is x sin x plus cos x. F dash x will be applying the product rule, x cos x plus sin x minus sin x, that is x cos x. So x1 putting x0 as pi, you get it as pi minus 1 by pi, which is 2.8233. And now we replace x2 by x2 will be x1 minus f of x1 by f dash x1. Substituting, we get x2 as minus 2.7986. Again, next step, we replace x1 by x2, which is minus 2.7986. So x3 is x2 minus f of x2 by f dash x2, which is 2.7984. Again continuing, replacing x2 by x3, we get x4 is x3 minus f of x3 by f dash x3, which is 2.7984. x3 and x4 are almost equal. So we conclude that the real root is 2.7984. I will just do one more problem. Use Newton Raphson's method to find the real root of x e raised to x minus 2 equal to 0, correct to 3 decimal places. So we have the exponential function here. As usual, we start with let fx equal to x e raised to x minus 2, taking the derivative f dash x equal to e raised to x plus x e raised to x. F of 0 is negative, f of 1 is positive. Again, between 0 and 1, if I take f of 0.1, it's negative, f of 0.3 is negative, f of 0.4 is negative, f of 0.6 is negative, f of 0.8 is negative, but f of 0.9 greater than 0. So we say that the root lies between 0.8 and 0.9, and we take let x0 is 0.8. So again we write x1 is x0 minus f of x0 by f dash x0. You can substitute the values using the calculator. So you get x1 is 0.8548. And f of 0.8548 is greater than 0. Now let x2 be 0.8548. So x2 will be x1 minus f of x1 by f dash x1, which is 0.8526. So now we replace x2 in the equation. So x3 will be x2 plus f of x2 by f dash x2, which is 0.8526. So the root will be 0.853 because we are asked to round it to 3 decimal places. So we have seen how incredibly simple the Newton Raphson method is once you know the approximate values to choose from. So thank you and stay tuned in for more.